Yo, what's up, everybody? Welcome back. Today we are doing a little Zig 015 upgrade day. We're in the context of our neural network project, which uses our, our standard library. We have like some library that we have that kind of we pull in some Zig code that we write on all of our projects. As far as I understand, the Zig 015 upgrade is not trivial. And so I think we're gonna like rip into it and just see what happens, So I've got Zig 015 installed here, and just running Zig build is like we start to see a lot of errors. And I did a like very, very short preliminary exploration here, and it seems like even fixing like the trivial stuff at the beginning, you start getting hit with like some more complicated stuff later. So I think let's just kind of try to work through it and see what happens. I think reading the patch notes first is probably the way to go. They usually have a lot of interesting stuff in there. So let's start there and move forward. Why are we upgrading? Well, because it's time, but also I hear it's way faster. They've got their like custom x86 backend finished, so I'm curious to see how that affects like our compilation speed as well as our like runtime performance. I'm curious to know if it will be slower noticeably or if it's just like pure wins. We'll see. Okay, so they're like, okay, can we turn this down a little bit? I can't really think Rihanna's too loud for me right now. Calm down. I can't think. Okay, so this is just like, what is Zig? Debug compilation is 5 times faster. The work in progress, ARM64 background is close, or backend is close. Writergate scandal, some language changes and standard library cuts, rocks the boat with huge API changes. A harbinger of async, await resurrection, the last bastion defending language stabilization. So I think I've heard about Writergate a little bit. I think that they're kind of working towards the idea that the IO interface is like not going to be how it is today at all. They're working towards like a like IO abstraction where you pass an IO to everybody and you use that to do like to like queue up stuff on some sort of like thread pool or some sort of like event executor. And so I think that they're like their new async await, as far as I understand, is very in line with how I would do it, which is nice, right? They're kind of saying like, hey, this is just like a fucking function. It's just a function on some interface. It's not part of like the language. It's just like a function. And that function, you will like queue up work and it will give you like completion events. And then you like wait for those if you want, or you like cancel them if you don't want. That's like my understanding of where they're going. And my understanding is that the first step in that direction is just like fucking up the entire IO subsystem. So that's what I'm expecting to come from this, but we'll see. Okay. They're like, yo, we got some targets. I don't really care that much about this because we're mostly doing x86. We probably will move on to ARM at some point, but I'm not really concerned. I'm sure that they have good compatibility for both. Yeah, so they're like x86 is tier 1, and then our ARch64 stuff that we might care about later is tier 2. Yeah, okay, whatever. Tier 2 is it works. Target has debug info capabilities and therefore produces stack traces. What is the okay? Wait, what's the difference between tier one, tier two? Tier 1, everything are known to work. I see. And also can work without LLVM. Got it. Sure. So this is like we need LLVM and we don't know if it works. ARch64 backend is in progress as far as I know. Yeah, I did see that. I saw that. Okay, I don't really care that much about any of this. Okay, language changes. Minor changes. Packed unions are no longer allowed to specify in a line attribute. Sure, I don't think I used that ever. Providing an override for the alignment previously did not affect the alignment of fields. So it's just like a fucking lie. Sure. Using namespace removed. I think we might use this. Do we use this anywhere? Using namespace. No. But I used to. So I think that the use of using namespace before was like you would basically it would be re-export everything without like being in a new namespace, right? So instead of going like const x is equal to import thing and then you do like x thing, you would just have like thing. And they're like, that's a fucking disaster. Get that shit out of there. I think that like before it was in the recommended docs to use this for like C imports, right? So you could kind of like write like a C wrapper module that like imported another generated module, and you would like export the generated module as yourself or something. And they're basically saying like, don't fucking do that anymore, I think. Yeah, so this simplifies like cogen slash like uh simplifies compiler implementation, sure. Find the identifier, blah blah blah. With using namespace, the programmer can be led in a wild goose chase. Yeah, it's like not good for like compiler and for us, I think. Yeah, for instance, autodoc cannot reasonably see through non-trivial uses, blah blah blah. They're like, fuck this feature. It's trivially traceable. Great. Encourages poor namespacing. Sure. When declarations are in a separate file, that typically means they share something in common, which is not sure with the contents of another file. Sure. As such, is a very reasonable choice to not do this. So they're saying like, I like this. This is like when I'm like, you're at work and you've like made a decision and you kind of just like fucking freeballed the decision and you're like after the fact being like, no, it's well justified. This has those vibes to it, right? They're like, we did this thing because it makes like up here, they're like, it makes my life easier, and then here they're like, no, but like for real though, on God, like you should be doing it though, and like not just because it made things easier. I'm sure that they actually believe this, but it's funny. Like it has like that vibe, where you're just like, no, I swear it's good. Conditional inclusion. You used to do this. You just don't have to do this anymore because dead code elimination will solve it. And so like they're like, you can also slap a compiler on there. Sure. Don't care. And then they had implementation switching. Sure. Here they're probably just saying, so before you would say like, hey, I might want to like export an init function for myself, depending on my implementation. Now they're saying, just make fucking functions and pass them along. Yeah, you can just like const init the function. Sure. Mix-ins. I'm sure they're going to say, just don't fucking do this, right? The alternative, so they're like, yeah, namespacing is good. Yeah, they're just going to say, don't fucking do this, right? I would never have ever typed this. And this is crazy. That's crazy. Yeah, sure. I'm all for not fucking doing that. Async and await keywords have been removed because they're going to be functions later, so fuck it. I have enough trouble being bad at writing Ziggs. I don't need an unfinished backend in the mix. That's totally reasonable. Switch on non-exhaustive enums. Now allows mixing explicit tags with this sprong. Sure, this will never come up for me. Like, sure, whatever. Additionally, it is now allowed to have both else and this. Oh, interesting. This is actually probably useful. So, like, you have an enum and you say, this could be any U32 value, but only A, B, and C are named. Here, you're like... Here, then you say, I'm going to look at A and B. This underscore covers all of the unnamed values, but I might have a named value that I wanted to handle specially. Like I might have multiple named values that I don't care about that I want to handle separately. Sure. Sure, we have better bool vector stuff, and by vectors here, they don't mean like array lists, they mean like SIMD types. Sure, that might come up for us. Type clobbers, sure. I don't really use inline assembly in Zig at all right now, but this is good to know. Doing mix-ins with a zero size field can be pretty good. It's just like, I feel like I would always rather just type the fucking like interface name, right? Like, it's just like the mix-ins feel like they just like are complicating things. Like I don't really have a problem with being like impl dot thing, right? And then like wrapping that function, right? Or like if I want that thing to be exposed, like just saying like const x equals impl dot x, like I'm fine with typing that. It like at least makes things more explicit to me, I think. Pointer cast can now coerce single item pointer to slice. Sure, doesn't really matter. Doesn't matter. New roles for arithmetic on undefined. Oh, that's interesting. Okay, so we now have standard rules for how when you have an undefined thing, What happens when you do like a plus undefined? In summary, only operators which can never trigger illegal behavior permit undefined as an operand. Any other operator will trigger illegal behavior. Sure. Generally, it's always best practice to avoid anything undefined. Yeah, I mean that's reasonable, right? If you expect undefined to allow like all sorts of crazy compiler optimizations, just like don't fucking do that. Sure. So they're kind of like doubling down. They're saying, hey, in safety mode, we'll like try to make sure that you don't fucking do that, and then in non-safety mode, like fuck yourself, right? Like, error on lossy conversion from int to float. Oh, that's cool. That's neat. That's neat. So they're saying like this value is not representable, and so like don't fucking type that shit. And if you want to do that, probably you can just do a manual int cast. Oh yeah, you just put a .0 on it and then it'll be okay. Interesting. Neat. Neat. Not very useful is not equally useless. Yeah, true. I'm sure you guys are just talking about stuff. I'm not sure if this is relevant to what I'm talking about anymore. So I'll just let you guys go at it. Sure, that's cool. Standard library. No more ooming on copy file. Sure. Atomic file now requires a write buffer in the option. What the fuck is atomic file? What is that? What does it mean? What does it mean? Atomic file. What is this? Directly access the file field and call atomic file finished to atomically replace desc path with contents. Oh, I see. So this is like you're doing like create a new file, write to that shit, and then do like a swap on the hard link at the end type shit. Sure. Now this guy is like taking file writer because Writergate, which we haven't got to yet. And then this guy's got, yeah, again, file writer, POSIX send file, removed in favor of FS file reader send file. Sure. Send file is now part of the reader interface. Right. Cool. Okay. Writergate, previous scandals. Let's start here. Alkgate. Oh, nice. Okay, that's not really relevant. All STD IO readers and writers are now deprecated in favor of the newly provided IO reader and IO writer, which are non-generic and have the buffer above the V table. Right. So in other words, the buffer is in the interface, not the implementation. Hype. Cool. This means that although reader and writer are no longer generic, they are still transparent to optimization. This means that although these are no longer generic, they are still transparent to optimization. All the interface functions have a concrete hot path operating on the buffer and only make vtable calls when the buffer is full. Oh, that's sick. Okay. Wait, that's sick. So you have like, it just means that because more is like north of the vtable, you get like you're auto buffered like all the time, and you can like work on that buffer for a lot of time until you run out of stuff. Then you go into the vtable and call shit. Sure. And like generally, anytime that you're gonna hit the vtable, then you're going to already probably be taking like a huge cost from like a syscall anyways. So it's like the vtable is like almost insignificant. Where before, if you had like buffered reader, you're hitting the vtable every time. That's sick. That's sick. Motivation. I watched this talk at some point. It was pretty good. Andrew is very charismatic, I think. To like maybe to like a certain subset of people. But when he talks, I'm just like that fuck yeah. Like it's just like entertaining, which is funny for like a guy talking about low-level Zig. So before everything had to be fucking generic. Fuck that shit. Old interface passed errors through rather than defining its own set of error codes. This made errors in streams about as useful as any error. Yep, okay. I mean, I use any error everywhere, but I could see why somebody would not want to do that. New interface has buffered interface, so fuck the buffered reader, buffered writer abstractions. Yep, new interface. Supports high-level concepts such as vectors, splitting, and direct file transfer. That's so cool. That's such a interesting interface. Like, I don't know if I've ever seen like an interface that is like so low level. It feels like it's like really targeting like high performance. New interface has peak functionality. Thank God, dude. Thank God. because we have buffer in the API. Great. If you have an old stream and you need a new one, you have adapt to new API. Old writer adapt to new API. Sure. So they're saying that the old interfaces, they're not gone yet. They're not fully gone. They're just deprecated. New IO reader and IO writer APIs. These ring buffers have a bunch of handy new APIs that are more convenient, perform better, and are not generic. So look at this read till delimiter works now. So we're like, take delimiter exclusive. These, okay. These strings, this is just like, great. I mean, cool, but this is just like a one-line function. So is he saying that, like, if you were to imagine it before, it would have been shit? Maybe. Concept of these streams also feature some unique concepts compared with other languages. Concept of discarding while reading allows efficiently ignoring data. For instance, decompression stream. Yeah, sure. So you're like, sure, you can skip decompression of entire frames. Oh, that's that's actually kind of hype. So they're saying you implement a reader API around a zip file, and you are seeking in that zip file or something, or you are reading but intentionally reading and discarding. It means that if you have like chunks of data that you know they're expanded length without decoding, you can just not do that part. Cool. Splatting while writing. So this is like a mem set through IO pipelines. That's sick. Send file also makes it through, which allows you to do file scripter to file scripter copies. Stream provides a buffer. Yeah, this is great. I mean, this is very compelling. This seems very good so far. FS file reader, FS file writer. So we memoize key information about file handles such as this stuff. Size from the calling stat, current seek position, error that occurred when trying to seek, sure. Whether reading or writing is done positionally or streaming, blah, blah, blah. Whether reading should be done from FD to FD syscalls or versus plain read. Oh, interesting. And we fulfill a SEIO reader. I would love to go look at this, to be honest. Can we try just reading from a file real quick and I just see how that feels? Pub function main. Like, what's it like now? We have standard library. Let's just take a peek skis. So current working directory, open file, right? Test text. Let's actually, can we pretend that we're doing like our CSV parsing, just like very, very loosely. So can we look at like experiment? Oh fuck me. Experiments. Can we just like here log? Okay, let's just like take a look and see what this feels like. So this feels the same so far. Feels around the same. And then we go F reader, right? Which does this now returns a... I'm in the wrong fucking spot. That's not good. That's really bad. This is the wrong fucking library. So... maybe I have to clear the cache. Maybe the ZLS is like relying on some shit. Maybe there's like a ZLS cache somewhere as well. Yeah, because I would love for this thing to work correctly. Okay, deleting the cache, great. Okay, here we go. Wait, open file. Const R is F reader. Does this work now? This now returns... This is still going to the wrong fucking spot. God damn it. God damn it, dude. That's annoying. Have you updated ZLS? I thought I did. Yeah, it is. It's just that it's using like systemzig instead or something. Or maybe we're in the wrong shell. Yeah, zig should like... We should only have this stuff, so... We might be having some ZLS issues. So I guess maybe we'll check out latest zig in another directory and go look at it there. Zig. Let's do that. You know, if this is just going to be that way. Oh, we might also be looking at like some like ZLS, cache ZLS. Yeah, like can we nuke this shit as well? Real quick. Maybe that's also infecting us in some way. Yeah, it's just going in the wrong spot. God damn it. Whatever. Whatever. Okay, we'll just look at it here. File zig. And can we look at function reader? So this guy returns a reader now. And this is their new implementation. Great. So how do I like get an IO reader out of this thing then? Because that's probably init interface with a buffer, probably, is what we're supposed to do now. Zig run test zig. Okay. So he's like expected 1 arguments. Okay. Oh, okay, wait, he's got a buffer already, and he calls init with this buffer. Okay. So then how do I get the interface of that? I guess we'll see. So var reader buff, we'll say we have like 4096 U8s here, and we'll slap that in here. Okay, and then reader, how does this new interface work? It's hard with the wrong fucking language server, but we'll make do. Pubconst reader. So here he's got interface as a field. I see. So we call interface on this guy. Oh, okay, wait, maybe this is working. What the fuck? Is this not the wrong spot? I thought it was, but does this look the same? Yeah, I mean, this looks like it's the new API, so maybe this is just like a fucking lie here. Maybe this patch, I thought that my patched zig was working on 0.14, but maybe it's not. Maybe I was confused. Okay, so maybe this is working fine. So IO reader, how is their interface initialized? This is kind of what I'm interested in. So they have like a vtable on this thing where they have stream, discard, and read vector. These are the only things that they have to implement. And I see. So they assume that the interface does not take like a context pointer. He assumes that he lives inside the file reader, and he gets a reference to like the file reader from doing a field parent pointer. So he's kind of saying like I have, you know, file reader here in memory, kind of sits here, and then I have like interface here. Interface sits here, and then you call stuff on this interface, and he goes like, well, the like rest of my data sits over here, and I know I live here, so I'm gonna like go to my address and like -5 to get to like the data address. The interface is not copyable around the same way allocator is. Yeah, that's how it looks to me based off what they're fucking doing here, at least. So, okay. So they have like vectored read, discard, and stream, and then the interface, I guess, must choose to like call these functions if it needs to, right? So if we call like IO reader read, we're like, let me just fucking, do I have like read all like we used to? Read slice all, I guess, is the new API here. So here they go like, this is on IO reader, this is part of the generic interface. They look at their buffer. So this is the output. They call read slice short, who does like operations on the buffer. And then if they run out, they call read vector. Yeah, which then we'll call vtable read vec. Okay, so maybe like the vtable read vec like you don't have a choice. Maybe you have to do vectored read. Yeah, this interface is actually very small. It's like stream to a writer, discard, do a vectored read, or what is rebase? Ensures capacity can be buffered without rebasing. Asserts capacities within this, blah blah blah. Default implementation moves buffer data to the start of the buffer. Oh sure. So you're like, I read like a bunch of data, and now I want to like copy that stuff backwards so that it's at the beginning of the buffer. Okay. Sure. So back to our like test zig. I guess we call like read. So we have vectored reads, or read slice will like kind of do that for me. I'm not the biggest fan of this. Like, I understand why your buffer is passed in here, but this is going, like, I can see myself getting confused by this, right? Right, like the idea that like I have a slice that this guy's using internally, and I call that reader buff, and then I'm like reading into out buff. This is just like, it feels a little confusing. But I guess we could get around this pretty easily by just doing like, since we just leak memory all over the place is like by design, we could do like try scratch alloc, you know. We could do this instead. And then we don't have like that buffer confusion. You know what I mean? That's probably how we will end up doing it. But sure. So we're like, I want to like read until, like there was like delimiter, right? Stream delimiter, peak delimiter, discard. So I'm like, I want to like read until a new line. So I guess we're supposed to stream the delimiter to something. So this, I see. So the interface is probably like, you have some array list, you know, out, you know, line buff or something, which we like back with an array list, right? Which now doesn't have like in it. Oh, you're saying there's like take delimiter? Oh yeah, maybe. It returns a slice of the next bytes of buffer data from the stream until delimiter is found. But what if the distance is farther than your buffer? You know what I mean? Like, doesn't that, what does toss do? Skips the next n bytes in the stream. Yeah, I see. So I'm assuming that this means that it has to fit in the buffer. Stream too long. Yeah. So we have like the happy path where it fits in this buffer, or we're like, it might be really fucking long, in which case we create like a line buffer here, and then we probably do like line buff writer here, and we're like, here is our allocator. Stood heap general purpose allocator. You know, we can probably do something like this. And then we can kind of do like stream till we find this guy. Yeah, it's probably like something like this. Does this fail? Yeah, and so we can probably do something like while true, we like line buff like clear and clear retaining capacity or something. Something like this. And then we say like stood debug print line with this line. Probably something like this now, right? So var here, right? And then he's like, whoa, is this thing failable? Whoa, what just happened? Writer returns a writer. No. So wait, who's he mad about? Stream delimiter? This thing can fail? Wait, what's he pissed about? Oops. He's mad that expected pointer. Oh, I see. Line writer is this. And then we return line writer like this is what he wants, I guess. Because the no, I'm confused. Expected IO writer found generic writer. Oh, is this wrong? Maybe the writer interface is deprecated instead of print or SCIO writer allocating. Oh, okay. Okay. Interesting. So this is writer states such that it writes the unused capacity of an array list, filling it up completely before making a call through the vtable, causing a resize. Consequently, the same optimized non-generic machine code that uses iReader. Whoa, whoa, whoa. What the fuck are we talking about? What are we talking about? Maintains writer state such that it writes to the unused capacity of an array list. That makes sense. Filling it up completely before we can call through the vtable, causing a resize. Oh, sure. Okay. I see. So, like, when the buffer gets... So, this is like a buffered thing. And when it runs out of room... Oh, I see. So we, like, give it an array list. He nukes the input array list. And then does his own shit. So we don't really want to do this. We can get an array list out the end later, and he will behave as if he's an array list, probably. Right? Like, is when they say array list here, are they like actually using array list, or they're saying it's like kind of like one? Growing rebase here comes from here. I see. So they are really using it, right? They're saying, yo, I'm taking my shit, turning it into an array list, calling grow on it. Yeah, okay. Interesting. So here it's really more like this. And I guess technically using from a array list here does kind of make sense. Because it means that this like clear retaining capacity will like preserve the memory of this overall. But then like how do I like flush this shit? I guess I guess it's like some sort of crazy shit like this. So we have like var writer is this like allocating writer. We stream into that thing, who's like got some sort of like, is it writer dot interface? How do we get from this to the writer? It's just dot writer. I see. Okay. Who needs a pointer to this guy? Who will modify this, and then at the end of this guy, we go like line buff equals writer to array list. And that way we were like using the same memory every time, I think. And here we probably just ignore this. And then we need to discard probably, right? Discard 1. Okay. Interesting. Interesting. I understand. I understand. So here we're supposed to like catch E and be like, if we're at EF, you know, if we're like end of file, we break lock, otherwise we return E or something, right? Probably something like this. Right? What's he mad about? Expected end of stream. My bad. My bad. Wait, what's the problem? Do I need to write like the error type? Do I need to do this? Yeah, I'm confused. This is stood IO reader. Do I have to do it like this for it to work? Yeah, I do. Okay, so now you're saying try it without the array list. I think it's easier that way. I do think that it's maybe different if I do that, but maybe we can kind of still kind of make it work. So what I wanted to do is I wanted to make sure that I'm reusing the same memory, so we're not allocating every time. But maybe we could get away with doing like writer out here. No, just none of that. So here you're saying like replace this with take delimiter. Inclusive, I guess, is kind of what we want. And then no discard anymore. And this just returns the thing. Ginger, it's okay. Chill. And now GPA is somehow not used because we have like an inline buffer. And here he returns something wrong now. Delimiter error. So can I just do like error here or something instead? Is that how this works? Yeah, there we go. And then we print line like this. There we go. Cool. Cool. I see. And then probably here, if we make this buffer like too short, this will start erroring out. Yeah, okay. I think I understand. You don't need your own array list when using SEI array or allocating. Okay, let's try that version of things. So we want our allocating writer here. So here we're saying initialize this thing with our allocator. Great, right? Allocating writer. Here I want to do like clear retaining capacity. Nice. This is what yeah, this is nicer. And then here, can we look at like do we need to do the to array list here when we print it still? Can I just look at like items? Let's see. Is there like an items thing in here? He's just got allocator and writer. How? Whoa. Where does this like array list come from then? It's w.buffer. Oh, so the writer interface itself is the array list. Oh, that's confusing, but cool, right? So we have like our writer interface here, right? And in him, he has this like buffer, right? That like we fed in externally before, right? But there's nothing saying, so the rebase is actually like about like replacing this thing. Like, so he's as allocating, he like knows that he can like adjust this as he wants. Ginger, come here. Come here. So that's cool. And so then like when we say like to array list, yeah, come here. I know, they're just doing fire testing. You're good. I know. Hey, all the way. Yeah, so then like the array list is actually backed by this buffer. That's very interesting. Interesting. So you're saying I can do this to get like the line buffer out of this thing? And this is just like this. Ah, that's okay, that's super nice. So my dumbass assumed that we were looking at this buffer here that's in the reader. But this buffer doesn't matter. This just affects like the amount of copies that we have to do into this array list. But like, it doesn't matter. Okay, that's hype. Wait, that's super cool. I think that so like for us, this is going to be kind of like a fun little experiment for us later where we're going to have to be looking at um so like our allocators are usually like super arena based, right? So this rebase thing that like frees and copies and writes and like allocates a new buffer, that's like really unfriendly to our usual workflow. So we might end up doing like something where we implement an IO writer for our like runtime segmented list, which is like a list of buffers that like continuously grow but like don't copy out. Like we kind of have like a list of like a 4 buffer, then an 8, then a 16, which like sums to 16 plus 8 plus 4 is like 30 or something, 28. Okay, cool. I think this all makes sense. This all makes sense. Compare with unbuffered read. I don't know how to do an unbuffered read anymore, which is kind of funny. Can you just do like f read, I guess? Yeah. So you can just do an unbuffered read like this and do it yourself. I believe it. I assume that this is just way fucking faster. Like you can just tell by looking at it. It's way fucking faster. Remap call in the allocator interface is your friend, so nice one that was added. But I don't think that remaps work nicely with arena allocators, right? Because I can't grow anything in my arena unless it's the last thing that was allocated. Right? Reader empty. Oh, yeah, I see. Unbuffered reads. I see what you're saying. Yeah, I'm not gonna do that, but I do think that you're right that that's an interesting thing to look at. I just want to like I gotta draw the line somewhere. Okay, so I think I understand this now. I think I understand. So now we have writer print. What's an arena allocator? Never heard of it. Basically like the way that like most of my memory management stuff works is I instead of having like okay, so like the Zig allocator is probably the general purpose allocator is doing something along the lines of he's got some sort of like internal storage for like like shit I have, right? And like shit I've used. And he is going to like when he allocates from the system, he's going to like mmap in like something that's at minimum 4K large page size, right? So 16K on some systems, 4K on ours. And he's going to like put that in like the shit I have buckets, right? And like he's going to like when things are allocated, he's going to like take this chunk of memory and put in shit I've used. This is no longer something that we can like allocate anymore. And as you know, you use this thing, you like when you free stuff, he takes like the shit I've used and like he's like, oh, okay, take this stuff and put it back in shit I have, right? And you end up with this like list of stuff, hand wavy, that's kind of like pages that you've allocated split up into like areas that you've like sent and received, right? And so like then you can imagine how like as you like allocate and free stuff, he might go like, oh, is there like a chunk of memory that I can use that like is for this thing or for that thing? Is it big enough? And you can imagine there's like some sort of like fragmentation that happens, right? As well as like just like a lot of like overhead in tracking here, which is like very useful in a lot of ways, right? Because you don't have to think about it. You're just like get free. What I try to do mostly is we have like an arena, which is literally just like there's a like standard library arena. Ours works like slightly differently, but hand wavy, you will be like, I have some memory, 4K, right? I am here. And if this is like 2K and somebody allocates 4K, we just say like, fuck this shit. Let's get like a bigger buffer that's like 10K long. And I am here. And anytime somebody allocates, I just like move the arrow forwards, right? Every time somebody allocates anything, we just move the arrow. And it means that like if somebody used this back here and then they free it, you don't really care. You just leak it, right? And then like all you track in an arena is like where am I and how much do I have left. And then when you run out of room, you like allocate more. And so it's kind of nice so that when you like free, all you have to do is like you no longer like free individual things, you free like pools of shit. So you're like all of this stuff that I allocated, just like free it all, which is like simpler. but it means that something like this allocating writer, who is going to like allocate and free and allocate and free and allocate and free as he gets bigger and bigger and bigger, is like wasting more and more memory. So like a better strategy or like a different strategy might be just keep what you had and allocate more and never get rid of anything. And so you'll have like fragmentation within your list of stuff that you're writing, but like as long as those chunks are big enough, it doesn't really matter, right? Like if those are each like bigger than a cache line, then there's like a little bit of extra work because it might have a little bit of a harder time guessing the gaps between, so it can't like pre-cache all of the next lines while writing, but like that cost is generally like okay type shit. And also if you happened to allocate back to back as you're growing, then like it's fine because you will pre-cache correctly anyways. So that's kind of, anyways, that's why I was saying like this won't work for our bump allocators as well as something that doesn't free. So we might have to look at that. Okay, so standard output thing. I actually like never use this shit. I always use std debug print like a fucking dumbass. Already wondered why you're using Arena. Is it too lazy to free your performance or non-vent here? Yeah, so there was like a whole like thing on this. I went through like this big rabbit hole at some point. But my big concern was that I don't like that I had error defers to free. The error defer debacle, yeah. So what I want is I want my happy path and my sad path to be the same. Especially like if we look at like our GUI framework, like we can just look at like our really simple example here. When we are constructing like GUI layouts, a thing that we will do is we will make a label and put that label into a widget or into a layout, right? And that layout, has, we're gonna like make a box and put this line graph in a box and put that box into a widget. And it's like this, without arenas or like some way to pool memory allocations at the very least, is like very difficult because every single one of these things allocates. And so you need to like have like an error defer stack that frees each thing on the way out if you fail. And then like your error defer case is basically like almost never hit in practice. So you have a bunch of like completely untested fucking code that is like actually really dangerous, right? Because like the chance of you double freeing because you typoed something in an error defer block is actually like really high, right? And so what we do instead is we like just put all of this stuff into pools and then free the pool when we go to scope, and maybe we like checkpoint the pool at the spot. We say like everything allocated after here, like if we go out of scope, just reset. If we fail, reset to where you were at the start. That type of thing, right? And so like using pools and arenas makes it way simpler. Like the arena is like not technically necessary. You could just have like a linear list of mallocs that you like free in reverse order. But the arena makes it like simpler because it just means that your cost of freeing is like one instruction, right? It's just like a subtract. So that's how we ended up there. Okay, so the compression stuff uses the new IO writers. Great. So wonderful, hot, sexy, whatever. No compression anymore. Sure, whatever. Counting writer deleted. So now we use discarding writers. We use discarding or allocating or fixed. Okay, cool. Makes sense. No more buffer writer. Yep, of course, because it's buffer for free. Oh, this is gonna fuck me. So we're not allowed to just put like empty squiggles in our prints anymore. We have to specify F to say, please call this formatter, which is fair. Because what? Interesting format method to instruct. Hold on. I've got someone here. I'll be right back. Fire inspection. All right. Sorry about that. Okay, so what is this fucking format? Why did they make this format change? Interesting format method causes struct to bug where formatting code somewhere prints with this and now starts rendering differently. Sure, I don't know if that's like a bug, but sure. Removing format causes struct caused a bug where formatting code somewhere prints this and now it's changed without notice. I don't really think those are bugs, but sure. So now you just have to put an F. Sure. This is just a good change. Yeah. Take a writer into the formatter instead. This is so much better. Holy, this is actually so much better. Yeah, because I always took like a format string and format options and then just like discarded them. I guess now in the writer, if you want a thing to behave a certain way, like you want your floats to be rendered in a certain way, that becomes like a property of the writer, probably. Deleted format options are now for numbers only. Any state that you got from the format string, there are 3 suggested alternatives. I mean, I didn't do any of this, so I don't really care. Format printing no longer deals with Unicode. Interesting. Previous implementation is not fully Unicode aware, so it was broken anyways, and so like we should just use some sort of UTF-8 helper shit. Oh, thank God, dude. You can now do fucking squiggle T, and then you don't have to write tag name and error name. You'll just get like the fucking text of an error. That's awesome. Integer printing can be used with custom types. It calls format number instead. Okay, interesting. And then this. So I see. So a lot of these like old structs we had like squiggle F to say call the fucking formatter. But now if we have a format number, then we will call that will still work. And then it's base64, sure. Degenericify linked lists. Interesting. So I think that this comes up for us. We're used to have removing the comp time format, debloated std format a lot. Oh hell yeah. So I bet you like you're saying like code size is probably like way fucking lower now. So this is very Linux kernel style linked list or like C style linked list where you have like this node type that is not generic. Before it was generic, now it's not generic. And your like linked list traversal probably like walks this list through node pointers, and then when you want to like get the data out of this thing, they're saying like use field parent pointer instead. Can we try this? Because I think this will come up in our like allocator stuff. Okay, so let's do something that's like std singly linked list. What are we looking at here? So we have a first guy, which is a pointer to a node. We have, some len, some pop. Okay, so if I say like, var L is this thing, right? I guess we have to like init this guy. How do we like make a new one of these? I guess kind of like this. By default, he's empty. And then we're gonna like append, prepend. We only have prepend, sure. And here we actually pass in a node, right? So we're like, here we'll say we have like list node. And here we hold like the node information here, as well as like the data. And then here we're like, we prepend the node. So we say like var, like const a is a list node. And here we have like node is, does this thing have like default initialization parameters? Yeah. So we're just like, this is empty and data is 1. Okay, and then we'll have b here with 2. And our singly linked list now, we say like append a node and b node. And we should be able to just like walk this list now. So we say like while like L, is there like iter? How do I like traverse the list? It must be like first, right? Var like iterator is kind of like this, while iterator val, we say like it is equal to val next, probably, right? And then here we say like if we want to print the data, we have to like go up a level, right? So we say like field parent pointer of, how does this thing used? You have, I'm looking for data from my field of val, right? And we say like, this is node, I guess. And then we have val here. something like this, and we do like std debug print val. And what we're expecting to see is this to go 2, 1, I think, if I like understand this correctly. So here we have to say that this is like a list node. Yeah, wait a second. So we're trying to go, given a pointer to the struct field, returns the pointer to the struct containing that field. So this is node here, and we're trying to get a pointer to our list node here. And then we print out val data or something. Something like this. Okay. So these things need to be variable, I guess. And there's a double pointer shit going on here, because this is like this, okay. There we go, nice. So this is 2, 1. So like that makes sense, I understand. Ginger, here, she's good. She's good. Okay, so that makes sense. That makes sense. So before you had like this generic type where traversal, like kind of you could like extract your nodes like had the type in them. Now they're saying your nodes are only tracking data, and if you want to get types like some data adjacent to that node, just like go up a layer, which seems fine. Sure. I don't really care about std progress. These HTTP client and servers now are completely abstract from TCP. That's great. We can probably almost nuke our entire HTTP library from this one change alone. Probably. So it's like container of, I see, yeah, exactly. Because we have like an HTTP thing that was kind of built because of the fact that I didn't want to work around stdnet TCP. I wanted to like hook it up to like an event loop with async. Like our epoll system. And so I think that if we can get IO reader and IO writer to like work with our epoll based versions, then we don't have to do anything. Like this will all just kind of work. So that's wonderful if we can make that work. Same with like Tails client. That's perfect. ArrayList make unmanaged the default, so we can upgrade to managed versions of this. Are we done with the neural network stuff, or is this somehow related and we took another detour? I just wanted like upgrade Zig, and so this is kind of like part of it. Right, like it's like orthogonal, but it doesn't mean that the neural network stuff is done. Like I'm going to be upgrading in the neural network project, if that makes sense. Okay, so this stuff is all fine. So they're trying to get rid of like array lists that hold allocators, because the vast majority of people who use Zig, I think, just like pass around one allocator everywhere. I think it gets confusing when we're managing multiple allocators, especially when we have like tons of pools, right? When we have like, pools with sub pools, and like we're trying to figure out like where each thing belongs. I like tracking them together, but I get where they're coming from, that like most people don't use it that way. They just have like one GPA. And so sure. They're saying you can use this stuff, but they will eventually go away. So like only do it as a stopgap. So what pattern does having an allocator field that does not having one doesn't? Avoid accidentally using the wrong allocator. This is something that we will do. And convenience when you need to pass, but there are downsides. Worse method function signatures, sure. Inability to statically initialize, sure. Extra memory cost, particularly for nested containers. Yeah, because you have to like store all the allocators. Yep, I agree. And they're saying this is not a conversational change with most Zig users. Yeah, okay, sure. They ditch a bunch of ring buffers because there were like fucking like 10 of them. Sure. Bounded array has been removed. To upgrade, so this was like a thing that before you say, I have like 100 bytes on the stack, and I just want to use them like an array list. But this is like a type that is like a stack buffer right now. To upgrade, categorize the code is an arbitrary, and they're like, we removed that. So is an arbitrary limit for which the bounded array is making a reasonable guess at an upper bound or deciding reasonable limits. Don't guess. Make that choice for the calling code. Accept a buffer or slices in input. Sure. So they're saying take in slices and use those. And array list now has bounded variants of all assumed capacity methods. Wait, that's good. Wait. So they're saying that if I have like a stack buffer, I have like a, 2 initialize or something, and this is going to be like 100 floats, right? Sometimes we say like for 0 to we usually we do like while like some event, but we'll say like for 0 to 10, right? Let's say we have 10 things, right? And let's make these integers for a second. We can say like we can say 2 init I is equal to I or something, right? But then we have like 90 uninitialized things, and like trying to keep track of that means that you have to like track this index externally. So like what you might do is instead you might try to put this thing in an array list. So you'd say like 2 init al is stood array list from u8 init buffer here, and we say like we are wrapping this guy, right? And now here we just say like 2 init al push append bounded I. And now this is kind of like working with this memory, and we don't need an allocator anymore. It will just kind of do this for us. And then we can use like 2 init al items here. And so this actually comes kind of being more like this. Right? Right? Kind of more like this. And this actually, I think, completely removes the use of our. We have a type called stud util runtime bounded array, which was very similar to stood bounded array, except that stood bounded array had a like fixed capacity that was like hard coded at compile time, so it like allocated like a stack buffer that was like part of the type. We wanted something that was like behaved like that, like we had a bounded array, but you could like allocate something of any size to get there. It seems like this kind of replaces that use case too, right? Because we can now do like init buffer try alloc, you know, like 100 F32s here, and then this behaves exactly like our runtime bounded array, our like runtime bounded array, and we don't have to maintain it anymore. So that's pretty sick. We can probably like completely nuke that type. I'm not a fan of the ArrayList glue 3 APIs, bounded, assume capacity, growing together. Yeah, I can kind of see like it's kind of hard because like you have this thing that like fundamentally is doing something very, very similar. I wouldn't be like opposed to 3 types, but I'm not that opposed to this either. Right? Like if I'm using it this way, I know I'm using it this way, and because the allocator isn't like a method on it anymore, like you're not going to accidentally type append, because here you now have to pass in alloc, which makes it like very, very clear that like it might do a reallocate, versus like assume capacity. I think that like this one is like sketchy to me, but like sure, I can see why somebody would want to do that. And then bounded is what I want to fucking use a lot of the time. Reallocate how much you know is going to exist, then just don't fucking think about it again. So I'll probably start using this. I might not remove the runtime bounded array type yet, but I might start using this instead. We'll see. Hype. So they like deprecated a bunch of shit. I mean, I guess the benefit is you can take one and not know what type it is. Yeah, I agree with that. That seems kind of sick. Build system removed implicit root module removed root source file and replaced with root module, I think. Yeah, got it. This actually came in 014, and I just completely ignored that shit. Okay, cool. So they're saying just do this now instead. Why? To demonstrate the benefits. Sure. So they're like, because these things depend on each other, then we can create all of these guys first, and then like have root modules of each of these guys. Sure. But instead, now you need to know which allocator should be used. But like, how do I say this? You don't have to. Yeah, like I mean that was a judgment call they made, that they called it in the release notes, that like yes, the managed types did save that, but the extra, they're like, for the most part, it's not a problem. And I do kind of agree with them. I think I use these things slightly differently than most, but the bounded versus unbounded is really obvious, right? It's like, do I think that I know already? Do I know that there's enough room? Or do I think that there's enough room? Am I like fairly confident there's enough room? And having bounded and no with capacity is like reasonable. I think the idea is that they said most people just pass around one allocator for everything. Yeah, I agree. And that seems reasonable to me. And I don't do that, and that's fine. I'll just deal with it. This stuff I don't really care about. Compiler, they have the x86 backend, super duper fast. Incremental compilation is better than it used to be. Great. And do all this shit, sure. If you have trouble figuring out how to do you know bin for your build? Yeah, sure. Okay. There's nothing really worth talking about here, I don't think. It's like fast. It's fast. Threaded code gen, hype. So again, fast. Allow configuring undefined behavior sanitizer at the module level. Oh, sick. Okay. I don't think I ever used that, but that's good to know. We can compile tests to an object file. Cool. Easy. I'm sure that that's useful in some ways. I don't ever use Zig in it. And then the rest of the stuff is like pretty minor. Okay, cool. So big things that we have to look out for. Array list defaults to unmanaged now. We have mega reader writer changes. Linked lists aren't generic. But I think that's mostly it, right? Oh, I guess like the build script stuff. And then format stuff as well. Format needs F now. But otherwise, not that bad. We should probably put like future, remove runtime bounded array. We don't need this anymore because it's handled by the array list. And probably completely remove HTTP module. I think that these are things that we can do now, but we don't have to do. So I guess let's just start trying to fucking compile stuff and see what happens.